There we go.
All right, so we've got Tim and we've got Mary. And Mary, thanks for having your camera on. I can at least look at someone as I'm talking. This takes me back to giving lectures during COVID and having to do Zoom a lot. Fortunately, I don't have to do that anymore. So if I'm a little rusty with my Zoom skills, please forgive me. Amber and Colden have asked me to talk to you a little bit about civil engineering and the construction management programs here at Oregon Tech, and how they relate to the Oregon construction industry, and then a little bit more broadly to construction engineering and management. So I'm Roger Lindgren. I'm a professor here of civil engineering and been involved with AGC. I was just telling Colden for about 25 years now. So got to know them when I started working at Oregon Tech, and we've had a good relationship these past several years. Mary, Tim, do you know much about Oregon Tech?
My son attended there a couple of years back.
Great. Tim, what did he study?
Medical microbiology.
Okay. That sounds like something not civil engineering, but I'm sure it was a good education. So just in case people don't know too much about Oregon Tech, and I'm really surprised as I talk to people around the state, some people are very familiar with us and others even haven't heard of us or have misconceptions about what we are. So with that, tell you a little bit about Oregon Tech's history. I'll do this very briefly. We date back to 1947, the same year that Portland State University was founded, and really Portland State and Oregon Tech were founded as vocational schools for training soldiers coming back from World War II. We transitioned into something called the Oregon Technical Institute in 1948. The story there is vocational schools is what the California prison system used to call their training programs inside prisons. And so California employers thought that our graduates were imprisoned up here in Klamath Falls. So we changed the name from vocational school to Technical Institute. We became known as OIT back in 1973. For many years, and this is where some of the misperception is, we were part of the community college system. So from 47 till 1960, we were organized with K-12 and community colleges in the Board of Education. And then in 1960, and then up to about 1965, we transitioned to the State Board of Higher Education with all the other four-year colleges in the state. And you can see that in our early years, we had some things like gunsmithing and machining, much more vocational skills that really related better to our focus as a community college. But we transitioned into bachelor's degrees in about 1960, and then to master's degrees as our top degree in 1995. So today, just past our 75th anniversary, we're one of 7 independent public universities now. As you know, the Oregon University system disbanded a few years ago, and we all reformed with our own boards. So we operate semi-autonomously, but we're definitely primary source of funding is the state of Oregon. So what we have at Oregon Tech is a small campus environment. We have about 2,500 students on campus, and we pride ourselves in having some very personal and hands-on education for our students. We have some great starting salaries. One of the statistics that our marketing folks want us to push is our starting salaries compared to our competitors in Oregon universities. We've spent quite a bit of time and effort in the past 5 years to improve our physical facilities, including some brand new engineering laboratories that I'll show you some pictures of in a few minutes. And then we also expanded beyond master's degrees into our first doctoral degree. First cohort was last year in physical therapy. So we now have a DPT program. So we span from associates all the way up to a professional doctoral degree. Getting at the facilities that I mentioned to you, little over half of the spending has been directed towards engineering. We built a new engineering building in 2021, and a couple of years before that, my department, civil engineering and closely related to construction, got some construction of our own. We spent about $12 million in renovating our civil engineering labs. Labs are a huge component of our education. Although we are, a university and we're rigorous with theory, we also strongly believe that students learn best by doing and seeing and touching. I'm a roads guy, so I design roadways and pavements. Nothing better than having students getting their hands dirty with soil, asphalt, and concrete. And so we do that in our facilities here in Klamath Falls. And I should have mentioned actually that we do have a number of campuses in the state, but our main campus is here in Klamath Falls, Oregon, and that's the only place where we have the civil engineering program offered. Our Portland Metro campus has some other programs, but not civil. So our Klamath Falls campus, if you hadn't had a chance to visit, got a beautiful location. About 250, 300 days of the year, we have some sunshine. They should have taken a picture when the sun was fully shining, but the shot there is our campus with Klamath Lake and Mountain Lakes Wilderness in the background. We have some wonderful success stories for our graduates. We rank very well on U.S. News and World Report and Georgetown University ranking, for example. We recently ranked #1 in Oregon on return on investment. So students are earning good starting salaries and maintaining those 5 years down the road. A way of showing that with some statistics. This is Oregon Tech compared to our 6 sister universities in the public system. And you'll notice that we kind of stand out there on the left-hand side from the rest of the crowd. We have starting salaries north of $60,000. That's an average for the entire university. For civil engineering last year, our average starting salary was $81,000. So our engineering programs tend to fetch even higher salaries than our health and science graduates do. So if it's civil engineering we're looking at, the number's even higher there on the left-hand side. And Oregon Tech students not only are doing well out the gate, but also maintain that earning differential 5 years after graduation. So here we are compared to our peers 5 years after graduation, still doing very well. So that's some basic things about the university writ large. Tim mentioned that he had a son that attended Oregon Tech. I'm not sure if any of the rest of you, I see we have a few more people on the line as well. If you've had a chance to visit us here, you know that we have small classes, that we have personalized attention to our students. And one of the reasons that I think that you as educators should steer some of your students towards us. Being a public university, we have open admissions. And I can tell you that at least in civil and in construction management, we have a lot of openings for students. So we're not in a capacity restrained situation. We can take as many students as you can send our way. I know Mary's teaching in elementary school, so it might be a few more years, Mary, before your students would be getting to us, but never too young to start thinking about what careers might interest your students.
That's been my focus in meeting with all of the contractors in the different apprenticeship programs, is it's never too early to start.
Exactly. And just planting a seed of people realizing that engineering and construction are viable careers for young women and young men. One of the challenges that we have in something called civil engineering is that a lot of students don't know what civil engineering is. They hear the word electrical engineering, and I'm sure even elementary students know that electrical engineering must have to do with electricity, right? So light bulbs and switches. I guess that's not a good light bulb picture. I'll have to change that with an LED bulb. And then they hear the word mechanical engineering and they think about mechanics and they think about fixing cars and trucks. And so people have a general sense of what mechanical engineers do. But civil engineers, like, what the heck do they do? So one of the things I do when we have, either junior high or high school kids visiting campus is I'll ask a question and I'll say, how many of you died today of a waterborne illness? And hopefully the answer is nobody, right? And then I'll say, anyone die today while driving through an intersection or a roundabout? And again, hopefully they'll say no. And I'll say, well, you can thank a civil engineer for having clean drinking water delivered to your house so you don't die of a waterborne illness. Thank a civil engineer for designing that intersection or roundabout to be as safe as possible. And then I ask them if a building has collapsed on them recently, and most often people will say no, and I tell them that they can thank a civil engineer for that. So civil engineers build infrastructure, right? We design and build infrastructure. We design, we like to think, our modern way of life. So the actual word civil is just a truncation of civilian, and civilian engineering back in the early 1800s was really anything that wasn't military engineering. So the military academy was offering an engineering program prior to 1824, but then a private school in upstate New York started up something, and they decided to call it civilian engineering. Around about the same time, colleges and universities in Britain were doing the same thing. So civil engineers came to be really the mother of all engineering programs. All those other ones, electrical and mechanical, nuclear, chemical, all the other types of engineering programs really spawned out of civil engineering, offering applied math and science to solving problems for the civilian world. So in today's environment, what civil engineers do is design and manage the construction of big things, right? We don't do electrical, we don't do mechanical, we don't do smaller things, we tend to do big things. Roads and bridges and water systems and pipelines and railways. And Colden had a group out this morning on the I-205 bridge, I believe it was, expansion over the Willamette River. Peter Hewitt and Sons is, I think, the general contractor on that one, Colton. And those are big projects. We have a mega project coming up. The new interstate bridge is going to be built, joining Vancouver, Washington, and Portland, Oregon. Can't remember how many billions of dollars that one's going to be, but we do these big things, but some smaller things too. Local and regional water and sewer systems, and in my part of the state, a lot of drainage and canals and water distribution for irrigation purposes. We also get into design of airport facilities, both air side and land side. So really all the built environment around us is what civil engineers focus on. So civil engineering at Oregon Tech is comprised of 4 big areas. The flashy one that most people have heard of, and if you can get any junior high students to even know what a civil engineer does, if they're going to guess, most of them would think about structures, buildings, and bridges. That's a big part. And structural engineering is a sub-discipline of civil. But we do a lot more than just buildings. Geotechnical engineering is focused on the soil under those buildings, building things out of soil or on soil. That bridge that Colden was visiting today is going to have some massive piers, and those piers have to be founded on very competent soils and rock deep underground. And so geotechnical engineers are involved with subsurface exploration and then designing so that we can properly support our facilities on top. And then water resources and environmental engineers spend a lot of their time dealing with moving water around, whether it's in above ground water systems like you see in the slide there, or whether it's below ground, whether we have it in piped systems. Civil engineers heavily involved with water transportation and delivery, sewage collection, sewage treatment, and other aspects of what we call sanitary or environmental engineering. And then finally, what I consider the fun one, but that's just because I've specialized in it for most of my career, is transportation engineering. So that's everything to do with moving people around on the surface of the earth. We don't deal with airplanes, but we deal with airports. We don't design the cars, but we design all the facilities upon which cars drive. So streets and highways and intersections and beautiful roundabouts like the one in the picture there. Civil engineering has been around Oregon Tech right from the start. I mentioned that the university started back in 1947, and we were one of the founding departments. Our program back then was called Structural Engineering Technology, and then we changed to Civil Engineering Technology in the 1970s. And then in 1997, we became accredited as a civil engineering program by ABET. And I just wanted to mention this. If some of you have high school students that you're talking to, and you're talking about engineering programs, there's still a lot of misperceptions around the state about Oregon Tech's programs. My program, Civil, has been accredited since 1997 as civil engineering. That's identical to the accreditation that Oregon State and Portland State, University of Portland, Washington State, all the other civil programs in the West Coast are also accredited by ABET. So some things we are not an engineering technology program. We're not a 2-year program. Many years ago we were, but we're not anymore. We're a 4-year bachelor's program, and we also have a 5th-year master's program. We started that up in 2009. While we have some graduate education, our focus is first and foremost on undergraduates, though. We have about 100 students in total and about 6 faculty. So if you do the math, our student to faculty ratio is great. The provost, of course, wishes it wasn't so great, right? She'd like to see more students, maybe less faculty. Well, no, she'd just like to see more students, and I would too, but currently about 100 students, 6 faculty. We all have PhDs in civil engineering. 5 of us are also licensed as professional engineers. So I used to work for a big heavy civil construction contractor. And then I worked for the Chevron Corporation for several years as a facilities engineer before I got the education bug and became a professor. So we have faculty with great industry experience and an opportunity to give students very one-on-one type education. We have an average of 20 to 25 students in our lectures and about, 10 to 12 students in our laboratory sections. So some great collaboration between faculty and students. We've got, speaking of those 100 students, they're very active. Our students travel around the country attending conferences, going to seminars. They are involved in student competitions. Our students design and build their own scale model of a steel bridge. It's about 25 feet long. They spend most of the academic year designing and constructing it. And then in the spring term, they go to some place in the country, compete against other universities in something called the Student Steel Bridge Competition. We do something similar with concrete. Our students design, build, and race canoes made out of concrete. They're involved in traffic bowl quiz teams. We've got a reinforced earth and foundations team. So we've got students that get really excited about one aspect of civil or another and get to meet other students from other universities. We also bring guest speakers to our campus. So some very active students. Our students come from primarily the Western US. I had to kind of stretch out the map here because we had a couple of applicants from Louisiana this past recruiting season. Normally my map ends at about Wyoming. So we tend to attract students from the Pacific Northwest, yes, but also the Southwest. You'll see a lot of blips on the map there from California, from Nevada, from Arizona, and Hawaii. I currently have 5 students from Hawaii in our programs. That's about 5% of our total civil engineering student count. Zooming in a little bit on Oregon, we have, as you would imagine, a lot of folks from the central valley, right? So up and down the I-5 corridor there from Portland down to Medford is where we get a number of students. Coos Bay, you made the map. So we had a couple of students come to us from Coos Bay in the recruiting cycle, which was last year that I used to build this slide. And then a few that are local, but the vast majority of our students are coming to us from outside of Klamath County. And about half our students actually come from out of state, with California being our biggest contributor of out-of-state students. And then I decided to zoom in a little bit on Portland. I know we've got some folks from the coast. I'm not sure if anyone on the call is from the North State, from Portland or Salem. Not seeing any hands or nods or anything. So we do get students every year from the Portland area. The interesting thing I find is that we rarely get students from the city of Portland, but we tend to get students coming and studying civil with us from areas like Tigard and Beaverton and Lake Oswego, Clackamas County, Oregon City, places like that. We've got some fantastic students. Our students, our best students can compete against the best in the country, and evidenced by some of the scholarships that they've earned. So this is just a laundry list. You'll see Associated General Contractors is on there. Also the Beavers Charitable Trust, those two organizations directly focused on the construction management side of civil. So our students do well in regional and national scholarship competitions. They also do well at those things that I mentioned, like steel bridge and concrete canoe. Here's a group that won first place in the steel bridge competition back in 2021. You'll notice they're all masked up there. They had to do remote for this particular competition. We didn't do quite as well in 2022, which is why I didn't show a picture from there. Had some good students, but maybe didn't do quite as well in 2022. So you can see the big steel bridge here that our students design, build, and assemble themselves. They do this as generally juniors and seniors, but everyone starts off by making bridges out of paper or spaghetti or toothpicks, tongue depressors. We've had all kinds of different building materials. Students start early with their design and construction skills, and then we grow them into full-fledged engineers by the time their 4 years with us is done. I mentioned that we are pretty proud of our facilities. We have big indoor facilities for doing asphalt pavement, for doing concrete. Here's some examples of some things that go on in our concrete lab. We've got a good relationship with the Bricklayers Union. They come down and although our students are learning how to primarily design concrete masonry unit structures, the bricklayers come down and teach them a little bit of the construction techniques. People say that they want engineers that know how things are actually built, not just how they look on paper. And we pride ourselves on preparing engineers that have those hands-on skills. So we've got this $12,000 lab expansion that I talked about. We have multiple structures and mechanics labs. I have a hot mixed asphalt lab, a Portland cement concrete lab, traffic simulation lab, a fluids lab, a geotech lab, actually 3 geotech labs, and a big student projects lab where our students get a chance to work on things. They also celebrate Halloween, and I thought I would take a picture of them dressing up their mascot, which is a skeleton. Don't know why their mascot is a skeleton down in the student labs, but it is. His name is Dr. Bones, and he attends lectures and goes out on recruiting events with our students. We are blessed with, like I said, having relatively small numbers of students, and that allows us to get on the road and take our students out. We travel to construction sites. We travel to conferences. I took a group of students to Washington, D.C., and we all gathered in the congressman's office, and we got to meet with our elected officials, attend a transportation conference, and kind of see how the sausage was made when it comes to funding for big public infrastructure at the federal level. About 15% of our students any given year. This year I did the math and we were pushing a little bit high of 20%. So this number is pretty solid as a baseline. So our students go off into those variety of fields, like I mentioned, structural and geotechnical and transportation. And some of them go to work for designers. They go to work for big or small engineering firms. They could work for, 2 or 3 person firms in small towns, or they could go work for some giant engineering firm like Jacobs Engineering that has tens of thousands of people worldwide. So our students go to work for engineering companies, but one of the big employment groups is construction companies. So here's some of the companies that our students have gone to work for in the last, say, half dozen years or so. Colden, you mentioned Kiewit that was on your project with, and I think you were also up to Knife River and saw them today. But whether it's Skanska or Hoffman or Granite, Hamilton Construction, some of these are local. Bechtel's a giant international company, as is Black & Veatch. Kiewit is international in scope. Knife River has an enormous presence on the West Coast. Now, what I didn't mention is a number of smaller construction companies that our students go to as well. But I thought I'd put some names up there that people might see as familiar. So that's kind of what civil engineering is in very broad strokes, what civil engineering education looks like at Oregon Tech, and then how our civil engineering grads are working in the construction industry. But then we have something new, hot off the press, not quite in place yet, but starting in fall of 2025. So in plenty of time for Mary's students at the elementary school there in Coos Bay to be prepared for. We're launching a construction management program here at OIT, like I say, starting fall of 2025. We've got some great support from a number of contractors through something called the Beavers Charitable Trust. A lot of Beavers members, it's the heavy civil kind of subgroup of the construction industry, which focuses on more on what we call horizontal construction. So vertical construction, the Hoffmans and the Skanskas of the world build things up. So they build factories and office towers and things like that, whereas heavy civil contractors tend to build things that are horizontal. So roadways, airports, underground systems, tunnels, water and sewer, all sorts of construction related to marine, so out there on the coast, wharf construction and dredging and that type of thing is all considered to be heavy civil. So we've got some really good support from the heavy civil industry and the Beavers Charitable Trust, and some great AGC partners as well that have helped us fund this program. This particular CM program is going to be housed in our business management department, which makes it a little different than the program that Oregon State offers. And by the way, I kid about Oregon State sometimes, but it's a great school with wonderful programs. They have a large civil and construction engineering program, and their construction program is housed within their civil engineering department. Tends to be a little bit more rigorous on the math and science. We've decided to house our construction management program in our business and management department. And this is a good thing to know for some students that might be inclined towards the field, but are scared about, oh, do I have to take, calculus and those sorts of things? Well, you can get into the construction management program, and the highest level of math you'd have to take would be college algebra. So it's really attainable from a math preparation standpoint. We're going to embed 2 summer internships into the 4-year program. So the university is going to really work with AGC and other partners to place students in meaningful 4-month internships, 2 of those, one after the sophomore and one after the junior year, so that students will come out and be really field ready. We're going to be focusing on, the basics of construction estimating and scheduling, planning and contract law, those traditional construction management things. But then because we're in a management department, our CM grads are also going to have human resources background and accounting and understanding about supply chains, understanding how the business side of construction works. In order to manage construction projects, there's a lot more to it than just the concrete and the steel and the wood. It's managing people and managing money. So our program is going to cover both aspects of construction, both the physical construction and then also all those background business skills that are required. We're starting with KCC, and we hope to expand our community college partnerships to have great transfer capability so that the Oregon transfer block module could come over, accounting for the majority of the first 2 years of the program. Stay in touch or reach out to me for more information on that. As we roll it out next year, we anticipate that we'll be signing more articulation agreements with community colleges. So, if you have students that you're teaching now that you think might be interested in either the more science rigorous civil engineering side of construction or more the business management approach to construction management, I think Oregon Tech might be a viable option for your students. And with that, Colden said that we might have some time for some questions. So I kind of gave my spiel, and hopefully the recording captured all that. And now I'm welcome to hear any questions or comments that you may have.
My name's Tim McNeil, and I have a question about the process of attending OIT.
Yeah.
After the first 2 years, is there an interview and application program for making it into the department?
Yeah, so it's actually really easy to transfer into OIT. So if someone has done 2 years at community college, etc., all they need to do is make application and put civil engineering or in 1 year's time construction management as their preferred major. And as long as they meet some basic GPA thresholds, then they're automatically accepted. So we don't have an interview process. We're not capacity constrained, so we don't have a quota. It's just a basic application with high school and any college credit transfer transcripts, and then we get you slotted in.
All right, thank you.
Did I properly answer that question, Tim?
Yeah, you did. You gave me the information I needed, because I know some of the programs at OIT, you get in your first 2 years and then you hope to make it into
Oh yeah. Oh yeah. Good point. We're not like the medical imaging program at all. So if you are admitted as either a first year student or a transfer student, then as long as you keep getting passing grades, then you continue through the civil program. Yeah, so there's no lockout of students at all.
All right, thank you.
Question is, can you kind of simplify for me, what's the big difference between a geotechnical engineer and an environmental engineer?
Environmental engineer. Okay. So you ask a good question, because there are, on all these areas, there are crossovers. So environmental engineering tends to be more on water treatment and wastewater treatment and other ways of either directly protecting the environment, as in people, or the environment as in plants and animals. Now, when it comes to contaminated soils, the remediation of those soils becomes both a geotechnical issue and an environmental issue. And so you'd either have a person who has a background in both geotechnical and environmental engineering, or you'd have a team of people bringing their different skill sets together.
Thank you.
Any other questions?
Are students,
Oh, go ahead.
is it able for, do you guys have housing on the campus for
We do,
students, or do
yeah.
they have to find their own?
No, we've got, right now, we have two different forms of housing. So we have traditional dorms, with a roommate and a bathroom down the hall, that type of thing. We also have what's called the village, and that is apartment style living, where you have your own room, and you share a kitchen and bath with either two or three other people. There's 3 and 4 bedroom units. And then we broke ground earlier this spring, and for winter, maybe fall of 25, but probably realistically winter of 26, we'll have a new 800 bed dorm facility coming online. So there'll be actually 3 different options for on-campus housing. And then there's obviously a lot of off-campus apartment and shared house type ideas. A lot of my students rent houses. They get 3 or 4 of their friends together and rent a house after their freshman year.
And my last question, I don't know if anybody else has their hand up, is talking with a lot of these apprenticeship programs, even being elementary, the thing they're telling me that I can do on my end is to start getting the kids to do collaborative teamwork, getting communication skills up.
Yes.
You already gave me one idea of building a bridge with a spaghetti or something, which is
Yes.
something you could totally do in elementary school.
Yes.
So what other skills, if any, can you offer me as an elementary teacher that could help kind of start? Because I see kids in 2nd, 3rd, 4th, 5th grade that are already bound for the trades. So
Yeah,
what kind of
exactly.
skills can I help them achieve to get there?
Well, I think, the hands-on things are really important because, building the bridges and having some fun with it is really important. Something really simple. And you're on the coast, so sandcastle building, right?
Oh, that's a good one.
Understanding how when sand is wet, it holds together in actually a pretty dense structure because of the adhesion of the water. When it's dry, it doesn't hold up. And you can do some really basic structural engineering things, introducing them to that just through sandcastles. And we start with that actually. We do a little sand demo, and then we reinforce it with strips of paper, and so it's a reinforced sand. So anything that's hands-on tends to capture people's attention. I totally agree that the teamwork thing is really important. The projects that my students go out and work on, that I had a chance to work on when I was in practice, are big things. No engineer does it alone. You work with several others, sometimes dozens of other engineers and scientists and construction specialists and lawyers and a whole bunch of, the teamwork goes well beyond the engineering realm. So yeah, teamwork, super important. But I think getting kids enthused about the fun of building stuff, that's what I would focus on in elementary.
Thank you.
Absolutely.
Hi, could I ask a question?
Yeah, absolutely. Go ahead.
Thank you. I've been in and out here. So I was just wondering, is there something that you can tap into that your school does, where there are projects that you create that are done by some of your kids in teamwork, that you actually go out and share what you've done, kind of like a show and tell thing with any learning group in the community, whether it's a STEM committee that meets at the library, once a month, or whether it's, do you guys have anything like that?
Absolutely. Yeah. We've got a really active group called the American Society of Civil Engineers, ASCE/AGC, Associated General Contractors. We have a student chapter, and one of the things that the student chapter does each year is they do high school and middle school, generally STEM outreach. So they get these toolkits that our National Association of Civil Engineers puts out, and they'll go out and they will work with students, usually in small groups and things like that, to do little demos. There's a little water flow demo. There's a little sandcastle construction demo. There's a little bridge demo. So yes, we do that, and we generally do that under the auspice of our student chapters.
Oh, great. So is there a way to see when those are being scheduled? Do you guys advertise that on a website of any sort? I know it's a long shot, but
Yeah, and that would be if you look at our oit.edu/civil website.
Okay.
And then if you want to reach out to me, my email's on the screen there. And I'm really easy. I'm the only Roger on the faculty. So if you just do a faculty search at Oregon Tech, we're not a big university, and so you'll find me. And I can let you know when we might be doing those. And in particular, if you had a school, and if we had a student who maybe graduated from your school or from the region, that's always really cool, because if we can, in fact, a few years ago, we did have some students that graduated from the sort of South Central coast, go back to the coast with ASC student chapter and do some demos at the high schools and junior highs that they had gone to.
Thank you. That's fantastic. It's exactly what I was hoping for, and what a great resource.
Absolutely. By the way, I'll comment here while I'm waiting for another question to come in. The gal on top of the table here in the asphalt lab, probably not following OSHA regulations. But as she put it, she was a little vertically challenged when it came to operating some of the lab equipment. But that's one of my students. I had her for 5 years. Started as a freshman student, and she stayed with me right through the master's degree. Did a lot of work in asphalt permeability, and then returned to her home state of Colorado to work for Kiewit Corporation, a giant company. She works for their engineering division, and now she's focused on road design and asphalt pavements with Kiewit. And I'll just point this thing out. I talked about starting salaries. Well, she got an offer way back in December to go work for Kiewit starting in June, and she's looking forward to it. And then in May, she got an email, and she was kind of worried this is going to be one of those emails that say, hey, we're going to rescind your offer. And they actually sent the email and they said, hey, we know you're probably getting some other offers out there, so we wanted to add $10,000 a year onto the starting salary that we had offered you. We just want to make sure that you consider us first. And so that's the kind of job market out there right now for civil engineers. Now, she's a fantastic young lady, and she did have multiple job offers. And I'm not saying that every student is going to get a $10,000, bump in starting salary, but she certainly did. So it's a great time to be graduating, great time to be considering studying civil engineering. The industry nationwide estimates that we're going to need about 50% more civil engineers than we're currently graduating from our universities nationwide. So that's a huge differential. Part of that is just we're doing more, and part of it is a retiring workforce. So there's just going to be a big increase, and there is this big increase in the demand for civil engineers. Any other questions this afternoon? Colden, you guys must have wore them out with the day's events.
I was just say doing this 3 days in might have tired a few people out.
Tim, did you have a question?
Yeah, I'm looking ahead at the school year, looking at the possibility of bringing students over to see your civil engineering program and
Excellent.
what you could do to try to get them interested.
Yeah. And so if you're willing to bring some students over, we will certainly take care of them. So one of the things we do is we'll tour them through our labs. This guy down at the bottom here, Dr. Riley, is one of our very active young engineers. And he's got this demo that he does with students where they design and test a bridge really quickly, right, kind of in real time. And they have to protect an egg from being crushed. And so people vote on what design to use, and it's really fun. It's kind of engaging with students.
I love that.
Yeah. And then we always have some, concrete, the world's most commonly used building material. Really, it fails explosively, which is fantastic in a lab, horrible to happen on the job site. You never want to see concrete fail, right? But we fail concrete all the time in the lab. So we mix up a whole bunch of concrete in advance, and we have a bunch of cylinders ready so that when students visit, we can test it with them. And students tend to love seeing exploding concrete. A little piece of concrete that carries 40,000 pounds of load, something like that. It's kind of cool for students. So Tim, we will take care of you. If you let me know you're coming, we'll make sure that we have some students and myself or one of our professors to show you around.
Okay, I'll try my best to get that to happen because I have a couple of young students. They both just finished pre-calculus and they're also both starting the 9th grade next year. And I just kind of have to look forward for them.
Yeah, yeah.
Kind of, training they can do. I think I'll be able to take them through calculus before we get through high school.
Yeah.
But I'm looking at maybe having interested them in engineering before we get that far.
That's fantastic. And people, I came from a civil engineering chairs from around the country got together and we had some education experts telling us about when students make choices about careers and things. And, I used to think, oh, you got to talk to high school students. And then it was like, oh, no, you need to talk to junior high students. But these people were telling us that it's actually elementary school. So people will start discounting things in elementary school, taking them off the table, thinking, oh, I could never be a doctor, I could never be an engineer back in elementary school. So they're telling us, they basically said, you need to forget about going into the 11th grade class. I mean, that's great, but you're kind of preaching to the choir there because those are students that are maybe taking calculus or something already. You need to get down into 3rd grade and 4th grade and be doing these, whether it's a popsicle stick or the spaghetti bridge building and things like that Mary mentioned, that's, so yeah, these middle school kids that you mentioned, that's absolutely a great time or even earlier to get them interested. The value of a campus tour, of course, becomes great once they're like 9th grade, 10th grade or something.
Well, yeah, I was looking at the value of a campus visit because the girls are so far along in math and other courses already. I think probably both of them have their associate's degree about the time they graduate from high school, and
right,
them pre-interested in the program.
That's terrific, and I'd like to introduce them. And I should have mentioned it, but out of the 6 professors that we have 2 women and 4 men, which is not parity, or it's not 50% yet, like the population, but it's a whole bunch closer than we were for the last 100 years. It used to be that engineering professors were all old white men, and that's just not the case anymore.
My concern isn't so much parity or interesting like that, just pairing students with and their abilities and interests with careers.
Absolutely. Yeah. We can definitely set up your students and hopefully inspire them.
Thanks.
And I'll just say, as a previous visitor of the facilities, they're pretty neat to go visit. Like the asphalt lab is fantastic, and just seeing them as a visitor is pretty fun, and you can definitely feel a little bit like a kid playing in like a science lab or something. So even without all the cool demonstrations, it's a fun place to go visit.
All right. Well, Colden said that it was going to come to an obvious end. So I think that's probably our obvious end, Colden.
I would say probably about right.
Yeah.
Unless someone has a last second burning question.
Last second burning question.
Do you have summer camps that get kids exposed to stuff there?
Yeah, we do. We don't have one going this summer, but our pre-college and programs department does put on, and we did have a couple of, I had some funding and did like a transportation summer camp for a couple of years where we focused on roads and bike lanes and pedestrian facilities and things like that. So those are on a well, let's just say not an annual basis, but as often as we can. They're expensive to run. Yeah, unfortunately.
Thank you.
Well, thank you, Roger, so
for all this
much.
valuable information. Yes.
Absolutely. It's been a pleasure talking with you all this afternoon, and you've got my name and email addresses out there, so feel free to reach out. Colden can get a hold of me anytime, so you can also get in touch with us through AGC. And hope you have a great you guys have the rest of the week, or is this it for the?
No, we have the rest of the week. We have 2 more days of site visits.
Oh, wonderful. Wonderful. Okay. Well, hope you have a great time and hope the weather is good, whether that means cool or whatever. Hope it's pleasant for your site visits.
Awesome. Thanks, everybody.
All right.
Thank you, Roger.
Thanks,
Thank
Golden.
you.